Welcome to aminacademy.com. In engineering mechanics regarding deflection of helical spring, let us solve some problems. Example, a body of mass 10 kg suspended from vertical mounted spring deflects it by 18 mm. Determine the number of oscillations of the body. Also determine the maximum force in the spring when it is displaced through a distance of 30 mm from its rest position and then released. Here we'll write the given things first. Here mass of the body, mass m equal 10 kg, and deflection delta equal 18 mm, which is equal 0.018 meter. Next, and displacement x equal 30 mm. That means 0.03 meter. Next, here n equal number of oscillation, n equal 1 over 2 pi square root of g over delta. So which is equal 1 over 2 pi into 9.8 over delta equal 0.018. So which gives 3.72 hertz. Now angular velocity omega equal angular velocity will write first omega equal square root of g by delta, which is equal 9.8 over 1.018, which is equal 23.33 radian per second. Now maximum acceleration. Maximum acceleration of the body equal a max, which is equal omega square x equal 23.33 square into x is 0.03, which gives 16.33 meter per second square. Now let us get more space for further calculation. Maximum acceleration is found now. Therefore, maximum energy of force on the spring equal mass into acceleration maximum. So mass is 10 kg, acceleration maximum is 16.33, which gives 163.3 Newton. Now, we also know that maximum force in the spring occurs when the mass is at its lowest position. In this position, the force in the spring is equal to the sum of the weight of the body and the inertia force. Therefore, maximum force. First, total sum of the body. Total sum of body is total sum of the force. Total sum of the force is equal uh, that inertia gravitational force, that is mass into 9.8 plus that inertia force is 163.3 newtons, which is equal 98 plus 163.3 newton, which is equal to 61.3 newton. Now let us do next question. The weight of empty cargo wagon is 300 kilonewton. On loading it with goods weighing 400 kilonewton, its spring gets compressed by 90 mm. Calculate its natural period of vibration when the cargo wagon is empty and loaded as above. Then second, it is set into natural vibration with an amplitude of 120 mm when empty. Calculate the velocity of the cargo wagon when its displacement is 50 mm from statistical equilibrium position. Static equilibrium position. Now let us start the problem now. First, weight of empty wagon. Weight of empty cargo is 300 kilonewton. When loaded, the W equal 400 kilonewton. Now, first we'll calculate the period of vibration when the wagon is empty. Now, period of vibration when wagon is empty. Here, for that we have to write first delta 1. Delta 1 means deflection of the spring is delta 1 when wagon is empty, that is 0.09 over 400 into 300. 300 is an empty, 400 is wagon weight, loading weight. So which gives 0.0675 meter. Next, time period T1 at this condition, that is 2 pi square root of 0.0675 over G 9.8, which gives 0.5212 seconds. T1. Next, we got first part. Then second, period of vibration when the wagon is loaded. Period of vibration when the wagon is loaded. At this condition, you will write first total weight. Total weight of the wagon, that is empty weight, is 300 plus load is 400, totally 700 kilonewton. Now delta 2 deflection at this condition is 0.09 over 400 into 700, which gives 0.1575 meter. Now time period for this deflection T2 is 2 pi into 0.1575 delta 2, that is over 9.8, which gives 0.7961 seconds. Now when the wagon is empty, the amplitude, this when the wagon is empty, the amplitude of vibration R, amplitude R equal 100.12 into meter, and the displacement let be this displacement is y, which is equal 0.05 meter. This 0.05 meter. Then omega when wagon is empty, 2 pi by T1, that is 2 pi by, already we have T1 is 0.5212, 0.5212, which is equal 12.05 radian per second. Therefore, velocity is V equal omega into square root of R squared minus Y squared. When loaded condition, that is equal 12.05 into 0.52 square minus 0.12 square, 0.12 square minus 0.05 square, which gives 1.31 45 meter per second. So we have done. Please subscribe our YouTube channel.